In this lesson, we'll look at how to take the subatomic particles that we've counted, our protons, electrons, and neutrons, and use them to build a model of the atom as per Bohr-Rutherford. Okay, so we'll call this a Bohr-Rutherford model. Now, the examples that I'm using here are lithium and sulfur, which I've previously worked with, and we know that lithium has 3 protons, 3 electrons, and 4 neutrons. And with sulfur, we know that it has 16 protons, 16 electrons, and 16 neutrons. And we're specifically looking at sulfur 32 and lithium 7. Okay, so we got this information by referring to our atomic number from the periodic table and the given mass number. So if you don't know how to do this step yet, then you should look at that first before you move on to this next step. Okay. So what Bohr's model shows is that the protons and the neutrons are in the nucleus, and the electrons are surrounding the nucleus in what we call the electron cloud. And what Bohr's experiments allowed him to do is to come up with a model where the electrons are actually on these different energy levels. And what he found was that a certain number of electrons could be held on a particular energy level. So in the middle here, you can see the results from his experimental work. This is one of these topics where we kind of need to dive deeper in order to really understand. And when you study Bohr's model in Senior 1 chemistry, you explore this even further. Okay? But for now, we kind of have to take this as fact that in an atom, there is the nucleus, which contains the protons and the neutrons. And then on each energy level, we can have a certain number of electrons. So let's look at how we build this. So for lithium, the number of protons that I have in the nucleus is 3, and the number of neutrons that I have are 4. Now there are different ways to draw these and represent them. I use a little box to represent my nucleus to keep it separate from the energy shells that I'm going to draw after. Okay? And sometimes you'll see that they just show the protons. So it depends on what you're being asked to show. In this case, I'd like you to show the protons and the neutrons in the nucleus. So for lithium, we've placed the protons and the neutrons. And now what we want to do is place the electrons. And the electrons are based on the energy levels. So the first energy level can hold a maximum of 2 electrons. So with lithium having 3, it's going to have 2 electrons. And I'll represent that with little sticks on the side. Sometimes you'll see models where you put dots, okay? Whatever is visible and clear. So I still have 1 more electron to place. So that means I'm going to need another energy shell. Okay? Try to make as good of a circle as possible on our tablet. So this here can hold 1 electron. Okay, so I'm going to put this 1 electron here. Now what you want to do for kind of ease of modeling here and ease of people being able to read is you want to think of there being spaces around your ring for the electrons, and it's 1, 2, 3, 4, 5, 6, 7, 8 as a general rule. So with lithium, I could have put 1 and 2. This is fine as well. Okay, but when you have more, which we'll look at with sulfur, we're going to fill in that way. It makes it easier for somebody looking at it to count the electrons that you've placed. And it also is giving us information that will be useful in the future model of the atom. So it's setting the stage for that one. So with this example with sulfur, I've got my protons being 16, my neutrons also being 16 in the nucleus. I've got 16 electrons to place, so I'm going to put 2 on the first energy level. I'm going to put 8 on the second energy level. So far I've put 10 electrons in my model. And now, and I should be giving myself more space here, but now I've got my third energy level. Now this one can fit 8 or 18. Okay, we're not going to reach that maximum point, but we've got 6 more to place. So I'm going to do 1, 2, 3, 4, 5, 6. Okay, so that is my model of the sulfur atom. Now for this piece here where I'm telling you 8 or 18, that's to be completely accurate. But the reality is we're going to be using this model for the first 20 elements. And so we're not going to have to worry at this stage about this part here, the 18. We're going to max out at 8 for our third energy level, and we'll bring in the fourth energy level when we need it. And that would be for an atom like calcium. Okay, so this is the kind of thing that you can practice, and I would really suggest, if you haven't done it already, to go through the process and draw the Bohr models for the first 20 elements. So from hydrogen to calcium, it will really help you when we move on to understand the patterns that you see in the periodic table. Now, the other piece of information that we want to look at here is how we can use the Bohr model to identify the valence electrons and then write a Lewis dot diagram. The valence electrons are the electrons in the outermost shell. Okay, so they're the farthest away from the nucleus, and those are the ones that are going to be really important to us when we start looking at bonding, because those are the ones, as you may have seen before, electrons are lost and gained. So we can lose electrons from our valence shell. We can also add electrons to the valence shell. So we want to be able to focus on those valence electrons. And so this is what a Lewis dot diagram does. It just shows us the element symbol and the valence electrons. And the positions of the electrons around the symbol are similar to what we had in our Bohr model. If I were placing electrons, I would use a dot. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so those are the positions for the electrons, again, for ease of reading, and also to make something correct later on that you'll explore when you look at what's called the wave mechanical model of the atom. So with lithium here, it's got 1 valence electron, so I can put 1 dot. Okay, there's not a correct or incorrect spot. I could put it in any of the sides of the square that you're looking at around. Okay, and oftentimes you'll see if there's 1, we'll put it there. With sulfur, I've got 6 valence electrons. So I've got 1, 2, 3, 4, 5, 6. Okay, I could also draw it like that. That would be fine too. Okay? You just want to quickly be able to see, okay, sulfur has 6 valence electrons.